Hey everybody, this video is going to talk about quadratic and square root inverse functions. So let's consider the function f of x equals x squared plus 2 for the domain 0 to infinity. Why do we only say 0 to infinity? Well, because usually x squared goes like this, right? And that's not a one-to-one function. So we have to restrict the domain in order to have a one-to-one function. Okay? So we want to find f inverse of x. So we say, well, y equals x squared plus 2. So let's swap the x and y's because we're flipping over the y equals x line. Subtract 2. X minus 2 equals y squared. How do we get rid of a square? We take the square root. And whenever we introduce a square root, we get plus or minus the square root of x minus 2. Now, because we have a domain of 0 to infinity, this is going to be the range of inverse. Remember, the domain of my function is the range of my inverse. So, how do I apply it to this? Well, this function is going to look like this for the positive portion, then it's going to look like that for the negative portion, right? I want to flip over the line y equals x, so I'm only going to consider the positive. I only need the positive root. So my function f inverse of x equals the positive square root of x minus 2. And then I'm going to graph it like this. And I can be more accurate in my graphing, so let's go ahead and do that. This point is at 2, 0. So it's going to be the point 0, 2. This point is at 1, 3. So it's going to go to 3, 1. And then this point is at 2, 6. So we're going to have a point at 6 and 2. Then we can fill in our function. So what is the domain? Let's see if it'll let me write this. What is the domain of f inverse? Well, the domain of f inverse I can find by looking at my function f inverse, and I can see that I'm going to go from 2 to infinity. Or I could look at the range of my function f, which also goes from 2 to infinity. Okay, so that's the domain, and the range of the inverse is just 0 to infinity because it's the domain of the original. Now let's do this function. We consider the function f of x equals x plus square root of x plus 5 minus 2. Okay, so how do we find the inverse of this function? Well, we say y is f of x, or our outputs. This was the square root of x plus 5 minus 2. When we flop it over the y equals x line, we swap x and y, so x equals the square root of y plus 5 minus 2. So we add 2 to both sides, and we get x plus 2 equals the square root of y plus 5. Now how do we solve this? Well, we have to square both sides to get rid of that square root. So I get x plus 2 squared equals y plus 5. Subtract 5 from both sides and I get y equals x plus 2 squared minus 5. So what is my function of my function f inverse? Well, it equals x plus 2 squared minus 5. So what is the domain of my original function is from -5 to infinity. So let's go ahead and graph that original function. It's a square root, and I start at -5 and I go on like this. Except for pause. I forgot to do the translation of moving this function down. So I'm going to go to the left 5 and down 2. So I start here, and then I go up accordingly. So it looks like this. Okay. Now my parabola, or my inverse is a parabola, but I'm going to go down -5, and then to the left 2. So I end up with a point here. And then I could do my flip-flopping of values, and I'll get a graph that looks like this. So what is the domain and range of f inverse? These are both of f inverse. Well, the domain is going to be the range of my original, or I can take it from here. And I'm going to go from -5. My domain actually goes from -2 to infinity. Now, if this was a regular parabola, it would continue on this side, but I'm only including the side that goes from -2 to infinity. And the range, I'm going to go zoomed in a little too much there. So for the range, where does my graph start? My graph starts at -5 and goes up. Now one more time, I want you to notice that the domain of my original function goes from -5 to infinity, just like the range of my inverse, and the range of my original function goes from -2 to infinity, just like the domain of my inverse. There's inverse functions.